What if everything you know about reality is wrong? What if the empty space around you, what seems like nothing, is actually alive with energy, filled with invisible forces, creating and destroying matter every second? We've been told that something cannot come from nothing, but what if that's not true? What if the very fabric of the universe is proof that nothingness does not exist, that even in the void, there is motion, potential, and the power to create entire worlds? This is not science fiction. This is quantum reality. And in the next few minutes, I'm going to take you on a journey, one that will change the way you see existence itself. Because by the end of this video, you won't just question what reality is. You'll question whether it ever existed at all. Let's begin. The universe, a vast expanse stretching beyond imagination, filled with galaxies, stars, and endless cosmic wonders. But what if I told you that at the most fundamental level, reality is not what it seems? What if the very idea of nothingness, the absence of all things, was nothing more than an illusion? For centuries, philosophers, scientists, and thinkers have pondered the nature of the void. What does it mean for something to exist? If you remove all matter, all energy, and all light, what remains? Would there be pure emptiness? Or is there something deeper, something hidden beneath the surface of what we perceive? For the longest time, the idea of nothing was taken quite literally. It was assumed that if you could strip away all forms of matter and energy, you would be left with a true vacuum, a space devoid of anything. But the 20th century brought with it a profound realization: nothing is never truly nothing. Quantum mechanics shattered the old view of emptiness. Instead of a passive void, physicists discovered that even in the most perfect vacuum, space itself is teeming with activity. It is not a static, silent emptiness. It is alive with fluctuations, energy, and the potential to create. At the heart of this revelation lies a fundamental truth. The vacuum is not empty. It is filled with what we call quantum fields, invisible entities that permeate all of reality. These fields are constantly shifting, vibrating at microscopic scales, even when no particles seem to be present. Imagine a calm ocean stretching to the horizon. To the naked eye, it appears still, but beneath the surface, currents swirl, waves form and dissipate, and an unseen energy moves through it. This is how the quantum vacuum behaves, a restless sea of potential. And here is where things become truly astonishing. If you manipulate these quantum fields in just the right way, matter itself can emerge from what appears to be nothing. One of the most striking examples of this is the Casimir effect. In the 1940s, physicist Hendrik Casimir proposed an experiment: place two uncharged, perfectly conductive plates extremely close together in a vacuum. According to classical physics, nothing should happen. But when the experiment was performed, an unexpected force pulled the plates toward each other, as if an invisible hand was at work. This force does not come from gravity, electromagnetism, or any force we typically observe in nature. Instead, it arises due to the fluctuating quantum fields that fill empty space. Between the plates, certain quantum waves are restricted, creating a pressure imbalance. This imbalance leads to an attractive force, proving that even the vacuum is never truly empty. But what if we go even further? What if we could create something more than just force? What if we could pull actual particles out of nothing? This is precisely what the Schwinger effect predicts. Julian Schwinger, one of the pioneers of quantum field theory, proposed that under an intense enough electric field, the vacuum itself would become unstable, spontaneously giving rise to particle-antiparticle pairs, electrons and positrons appearing out of nowhere. For decades, this idea remained theoretical. The required electric field strength was thought to be achievable only in extreme cosmic environments, like the intense fields around neutron stars or black holes. But in 2022, something remarkable happened. Using an advanced setup with graphene, a single layer of carbon atoms arranged in a hexagonal lattice, researchers at the University of Manchester observed a version of the Schwinger effect in a laboratory. By applying a carefully tuned electric field to this exotic material, they witnessed electrons and holes forming spontaneously, a direct analog to the quantum creation of particles from nothing. Think about what this means. This is no longer just speculation or science fiction. We have now seen matter emerge from empty space, a prediction made decades ago that has finally been verified. And so, we return to the question, is there such a thing as true nothingness? The answer, as modern physics reveals, is a resounding no. Even in the most absolute vacuum, there is structure, there is energy, there is the potential for creation. What does this tell us about the universe? It tells us that reality is far stranger than we ever imagined, that beneath the surface of what seems ordinary and mundane lies a hidden world of dynamic, ever-changing forces, that existence is not static, but an endless process of fluctuation, emergence, and transformation. And perhaps most profoundly, it tells us that everything we see, everything we are, could have originated from what we once thought was nothing. The ancient question, why is there something rather than nothing, takes on new meaning in light of quantum field theory. Perhaps the answer is that nothingness itself is inherently unstable, a cosmic sea of energy so restless that it could not remain empty. Instead, it gave rise to the fundamental building blocks of our universe. Some physicists even propose that the entire cosmos could have begun as a quantum fluctuation, a moment where the vacuum, in its infinite potential, birthed reality itself. Of course, the mysteries run even deeper. We still do not fully understand why the universe ended up with more matter than antimatter, or why the cosmic vacuum behaves the way it does. But what we do know is that the old idea of a static, empty void is a myth. Instead, we live in a universe of fields, waves, and forces, a universe where emptiness is never truly empty, and where creation is woven into the very fabric of reality. So the next time you look into the night sky, into the vast darkness between the stars, remember, what appears as nothing may, in fact, be everything. If the vacuum is never truly empty, if the fabric of space itself trembles with unseen energy, then we must ask, where did everything come from? The atoms that make up your body, the elements that form the stars, the vast galaxies scattered across the cosmos, where did it all begin? For centuries, humanity has sought answers. Myths and legends tell of gods forging the cosmos from chaos. Philosophers pondered the nature of existence, questioning whether the universe had always been, or if it had emerged from some unknowable void. And then came the discovery that changed everything. The universe, we now know, had a beginning, a single moment when all that we see, all that we are, erupted into being from an unimaginable singularity. We call it the Big Bang. But here's where the mystery deepens. If everything, the galaxies, the stars, even space and time itself, began in that moment, then what came before? The common answer? Nothing. But now we know that nothing is not so simple. Physicists propose that before the universe as we know it, there was a vast quantum vacuum, not empty, but alive with fluctuations, rippling with energy, teetering on the edge of existence. And then, a fluctuation, a momentary spontaneous tremor within the quantum vacuum, set everything in motion. You see, quantum physics tells us that particles can emerge spontaneously from the void, provided they obey one fundamental rule: Energy must be conserved. Think of it like this. If you reach into an empty bank account and try to withdraw money, the transaction is impossible. But what if, for the briefest instant, the bank allowed you to take out a loan, a temporary borrowing of energy that must be repaid just as quickly as it appeared? In the quantum world, this happens constantly. Particles flicker into existence, then vanish before reality can catch up. These are what physicists call virtual particles, ephemeral, fleeting entities that exist just long enough to leave their mark on the universe. And in the very first moments of the cosmos, something extraordinary happened. A quantum fluctuation, a tremor within the nothingness, did not vanish. Instead, it expanded. Rapidly, exponentially, unimaginably fast. This is what physicists call cosmic inflation, the moment when a minuscule pocket of the quantum vacuum exploded outward, stretching into the vast expanse we see today. And from that moment onward, reality as we know it began to take shape. Subatomic particles formed, colliding, annihilating, and leaving behind the fundamental ingredients of matter. Energy condensed into mass, forces separated. The cosmos, once a uniform sea of plasma, began to cool. The first atoms formed, then stars, then galaxies, then the structures that would one day give rise to planets, to life, to thought. But it all began with nothing. Or at least what we once thought was nothing. The implications of this are staggering. It means that existence itself is woven into the fabric of the quantum world. It means that the universe did not require a cause in the traditional sense. Instead, it emerged from the laws of physics alone, from the unpredictable yet inevitable dance of quantum fields. And if this is true, then could it happen again? Could there be other fluctuations elsewhere in the vast cosmic vacuum, birthing entirely separate universes? Many physicists believe so. This is the idea of the multiverse, a reality where countless universes may exist, each spawned from quantum fluctuations, each governed by its own set of physical laws. Some of these universes may be like ours, with stars and galaxies and life. Others may be utterly alien, ruled by different forces, shaped by different physics, forever inaccessible to us. And in this grander picture, our own universe is just one of many. But let's bring our focus back to something closer to home. What does this mean for you? For everything you know? It means that at your core, you are not just a collection of atoms, not just a being made of matter. You are part of the great unfolding of the cosmos, a ripple in the quantum sea, a brief but profound manifestation of the universe's infinite potential. You are not separate from it. You are it. The atoms in your body were forged in the heart of stars. The forces that hold you together are the same ones that shape galaxies, and the energy that animates you, the life that you feel, is drawn from the very same quantum fabric that gave birth to existence itself. So the next time you gaze at the night sky, at the endless dark between the stars, remember, what appears empty is never truly empty. What seems like nothing is the foundation of everything. And from the fabric of reality itself, new worlds may yet emerge. If everything, the galaxies, the stars, the very atoms that make up your body, emerge from the restless fluctuations of a quantum vacuum, then what does that say about reality itself? What does it mean to exist in a universe where nothing is truly solid, where the foundation of all things is not matter but fields and probabilities? The deeper we look, the stranger things become. At everyday scales, reality appears predictable. If you drop an object, it falls. If you push something, it moves. These are the laws of classical physics, the familiar rules that govern our day-to-day lives. But at the quantum level, beneath the surface of what we perceive, the universe does not behave in the way we expect. Particles do not exist in definite locations. Instead, they spread out like waves, existing in multiple places at once, governed by probabilities rather than certainty. A single electron does not take one path from point A to point B. It takes every possible path simultaneously. It is only when we observe it, when we measure it, that it suddenly chooses a definite position. This is the paradox of quantum superposition, the idea that a particle can exist in multiple states at the same time until it is observed. And this raises a profound question. Does reality exist before we look at it? The famous double-slit experiment revealed just how strange the quantum world truly is. When individual electrons are fired at a barrier with two slits, something unexpected happens. Instead of behaving like tiny particles passing through one slit or the other, they act like waves, interfering with themselves, creating a pattern as if they had passed through both slits at once. But the moment we place a detector to observe which slit the electron actually passes through, the interference pattern disappears. The electron suddenly behaves like a classical particle, choosing a single path instead of existing in multiple possibilities. It is as if the act of observation itself collapses the quantum wave of probabilities into a single reality. Music swells, enigmatic, filled with a sense of cosmic intrigue. But what does it mean to observe something? Does it require consciousness, awareness? Could it be that the very act of looking at the universe is what brings it into being? Some interpretations of quantum mechanics suggest exactly that. The observer effect implies that reality is not set in stone, that before measurement, before observation, reality exists only as a cloud of possibilities. So, if observation collapses reality into form, then who or what is the ultimate observer? Did the universe exist before conscious beings emerged to perceive it? Or did consciousness itself arise as a fundamental aspect of the cosmos, woven into the very fabric of reality? Music deepens, layered textures of sound, evoking a sense of something profound yet just out of reach. There are those who believe that consciousness is not an accidental byproduct of evolution, but something more fundamental, a force intertwined with the laws of physics, just as fundamental as space and time. The von Neumann-Wigner interpretation of quantum mechanics suggests that consciousness itself collapses the quantum wave function, that without a conscious observer, the universe remains in a state of pure potential. It is a controversial idea, but one that forces us to confront an unsettling thought. If reality depends on observation, then what does that say about our role in the universe? Are we merely passive beings drifting through a cosmos that existed long before us? Or are we active participants, shaping the very fabric of reality simply by perceiving it? And here, we find ourselves at the intersection of science and philosophy. Physics gives us the equations, the probabilities, the models to describe how things work, but it cannot tell us why. It cannot tell us what it all means. And so, we are left with questions that echo across time, from the first human minds that gazed at the stars to the physicists at the cutting edge of quantum mechanics today. Is consciousness fundamental to the cosmos? Would the universe still exist if there was no one to observe it? Or is it only through our awareness that reality is brought into form? These are questions with no easy answers. And yet, in their mystery, they reveal something profound about what it means to be alive, to be human, to be part of this unfolding reality. We are not merely specks of dust in an indifferent cosmos. We are the awareness of the universe itself, a way for reality to observe, to question, to wonder. And perhaps, just perhaps, That is the greatest mystery of all. Imagine this. You are standing in a vast empty space. There is nothing around you. No walls, no ground, no sky, just an endless void stretching in every direction. But then, something changes. A ripple. A flicker of energy, subtle at first, like a whisper in the silence. And then suddenly, the void is no longer empty. Particles emerge, blinking into existence, as if summoned from the depths of nothingness. They swirl, collide, vanish, reappear. An entire dance of creation unfolding before your eyes, born not from matter, not from some pre-existing substance, but from the restless energy of the quantum vacuum itself. You are witnessing something impossible, and yet it is real. This is not science fiction. This is the true nature of reality. And if you could see the world for what it really is, beneath the illusion of solidity, beneath the structures and forms we take for granted, you would see that nothing is ever truly still. Even in the quietest moments, the vacuum of space boils with quantum fluctuations, constantly birthing and annihilating pairs of particles so quickly that we never notice them. But what if something changed? What if, instead of vanishing, these particles remained? Could we, somewhere, somehow, harness the power of creation itself? There are those who believe this is not just possible, but inevitable. The experiment that should have been impossible. There is a story, one whispered among physicists, never officially recorded, a tale that exists in the shadows of scientific history. It begins in a hidden laboratory, far from the eyes of the world. A team of researchers obsessed with the mysteries of quantum mechanics devised an experiment unlike any before. They sought to create something from nothing. Using an array of high-powered electromagnetic fields, they attempted to reach the Schwinger limit, the point at which the very fabric of space itself becomes unstable, the point at which the vacuum gives birth to real particles, violating what we once thought were fundamental laws. The machine was built in secrecy. No government approvals, no peer-reviewed papers, just a handful of brilliant minds willing to push the boundaries of reality itself. And then one night they turned it on. For a moment nothing happened. And then the impossible began. A deep hum filled the room as the field grew stronger. The very air seemed to vibrate with an unseen force. Then came the flickers, tiny bursts of light appearing out of nowhere, particles forming from empty space. At first, they followed the expected patterns, appearing and disappearing in accordance with quantum laws. But then, something changed. The flickers stopped vanishing. The particles that should have been ephemeral remained. The researchers stared in awe. Matter, real, tangible matter, was emerging from the void, from absolutely nothing. They had done it. They had created something from nothing. But before they could celebrate, the readings on their instruments shifted. Something was wrong. The field was still growing on its own. They tried to shut it down, but the power had taken on a life of its own. The field was now feeding itself, pulling energy from the vacuum, expanding beyond control. The hum deepened into a roar. The air crackled. The room itself seemed to distort, space warping, twisting at the edges. Then, for a brief moment, reality split. One of the researchers, just for an instant, saw beyond. What they glimpsed has never been described. They never spoke of it again. But when the machine finally powered down, one thing was clear. They had opened something, and something had looked back. What lies beyond the quantum veil? This story, of course, is only a legend. Or is it? While no such experiment has ever been officially confirmed, the principles behind it are not mere speculation. We now know that vacuum energy is real, that the quantum fabric of space can be manipulated. And if we can manipulate it, how far can we go? If matter can be created from nothing, then what is stopping us from taking it further? Could we one day create entire realities? Could we engineer a universe from scratch, summoning existence from the void just as nature did with our own cosmos? Some physicists believe it is possible that, given the right conditions, we could one day induce a new Big Bang in a controlled environment, seeding a new reality from the quantum vacuum. And if that is true, then perhaps our own universe was created in the very same way. Not by a god, not by chance, but by something or someone before us. The simulation hypothesis: is reality engineered? There is another idea, one that shakes the foundations of everything we think we know. If we have the potential to create realities from nothing, then how do we know our own reality was not created in the same way? Could our universe itself be an artificial construct, a simulated cosmos running on some vast quantum system beyond our comprehension? Some of the greatest minds in physics have seriously entertained this possibility. If reality is governed by rules, mathematical laws, predictable patterns, then who wrote those rules? If space itself is quantized, if time unfolds like frames in a program, if the particles that make up reality behave like data, then is the universe simply a grand computation? And if so, who or what is running it? The final question: what are we? We began with a simple question: can something come from nothing? The answer is yes. And yet the deeper we go, the more the lines blur. Nothingness, it turns out, was never truly nothing. The void itself is alive, restless, brimming with energy, waiting, perhaps, to be shaped. But by whom? By what? By the fundamental forces of nature, by unseen cosmic architects. Or by us? Maybe we are not just observers of the universe. Maybe we are the creators. Maybe, just maybe, the act of questioning itself is what keeps reality unfolding. And as long as we continue to wonder, to explore, to seek, the universe will keep creating itself out of nothing, forever. The universe is not silent. It speaks in the language of energy, in the rhythm of forces unseen. Every moment, in every corner of reality, something is happening. Particles flicker in and out of existence. Waves of probability collapse into form. What seems still is never truly still. And yet we continue to ask the same question: where did it all come from? The story we tell ourselves about the beginning of everything is incomplete. Science has taken us far, revealing a cosmos governed by elegant equations, but there are gaps in the narrative, places where the light of knowledge fades into shadow. What was there before the Big Bang? The standard answer is nothing, but as we've seen, nothing is never truly nothing. Physicists now believe that before time began, the quantum vacuum stretched across an endless, timeless expanse. It was not empty. It was a seething ocean of potential, filled with fluctuations so brief, so fleeting, that they left no trace. Until one of them didn't. A fluctuation so powerful that it expanded instead of vanishing. Space itself stretched outward, unfurling in a violent, exponential explosion. This was cosmic inflation, a moment when the vacuum energy of the universe unleashed itself, giving birth to the first particles, the first forces, the first hints of what would one day become stars, galaxies, and life. A universe from nothing. But here's the strangest part. The equations that describe this process don't require a reason. There was no external force, no divine intervention. The laws of physics alone were enough to create a cosmos. And if this is true, then there is a chilling implication. If it happened once, It can happen again. Somewhere in the depths of the quantum void, another fluctuation may already be unfolding, another universe, growing, expanding, oblivious to our own. Perhaps infinite realities exist, each born from the same fundamental process, each governed by its own unique laws. If that is the case, then what does that make us? Are we merely the byproduct of a mathematical inevitability? A momentary consequence of quantum fluctuations? Or is there something more? There is one mystery that remains unsolved. Consciousness. We know the universe exists. We can measure it, model it, predict its behavior with astonishing precision, but we do not understand why we are aware of it. Why does the universe need observers? Why do particles remain in a state of probability until they are measured? Why does looking at something, simply perceiving it, cause reality to take form? It is a question that has haunted the minds of physicists and philosophers alike. Some believe that consciousness is an emergent property, nothing more than a side effect of biological evolution. Others suspect something deeper. That consciousness is not in the universe. That consciousness is the universe. And if that is true, then we are not simply in reality. We are reality, observing itself, shaping itself, collapsing the wave function of existence into being with every thought, every question, every act of wonder. Perhaps the act of asking, why does something exist instead of nothing, is the very force that ensures existence continues. Perhaps reality is an infinite mirror, forever reflecting back at itself, unfolding in ways we cannot yet comprehend. Perhaps we are not separate from the fabric of the cosmos. Perhaps we are the fabric of the cosmos. And if that is the case, then we have always been here, even before time began, even before the first spark of creation. Because in a universe where nothing is truly empty, in a universe where something can always emerge from nothing, we were always waiting to be discovered. And we are still discovering ourselves. Forever.